Started talking yesterday about what we call logical reasoning, and specifically we talked about conditionals, and right here we have the word converse of a conditional. We also mentioned words like counterexample, that disproves a statement, disproves a conjecture, which was another word. So just a quick review of those before we jump into this. We talked about two types of reasoning. And did anybody think of a good example of inductive reasoning from yesterday? So a conjecture is something that we conclude from reasoning. And so you're doing this pretty much every day, even if you don't name it. You're observing patterns, coming to conclusions based on those patterns, and often making decisions based on that. Or you're doing, like the green one, you're doing deductive reasoning, where you're applying a already generalized concept to a specific situation. And then those often result in conditionals. So if something is true, then something else happens because of it, is a typical form of a conditional. The converse is where we rewrite that in the reverse order. We switch the hypothesis and conclusion of the original. So in these, if Alicia scores 85 or greater on her test, she will earn an A as her final grade. That's the conditional, the if-then, and then it says she scores 89 on her test. What can you logically conclude? She got an A, right? As her final grade. So let's rewrite this real quick. What is the hypothesis of the original underlined conditional? Yeah, so if she scores 85. And then the conclusion, so that's the hypothesis. The conclusion is that she'll earn an A. So we just reverse these. So if Alicia earns an A as her final grade, then what? 85 or higher, etc. Okay?
Excuse me, sorry.
Whoa. I would prefer if you didn't do that again.
Okay, sorry.
Okay, how'd that one go? Did you get the conditional rewritten backwards? Get the converse? Raise your hand if you got it. Let's freaking engage occasionally. Thank you. All right, next one. If you finish the race in under 30 minutes, then you win a prize. So if you win a prize, and of course this is specifically talking about this race. If you win a prize, then what? Okay. Raise your hand if you got that one. Few of you. The rest of you study this stuff tonight, please. This will be on your test, your next test, or quiz, I guess we'll call it. It will be on there, so make sure you're studying it. Specifically like what we're doing here. Okay, and then we saw one like this yesterday. So if Kenji plays a brass and plays a brass instrument, then he plays trumpet. And I'm writing this fast, so if you can't read it, let me know. Okay, so how'd you do on that one? Raise your hand if you got the converse correct on that one. Okay, so 3 of you. And then again, the logic part of this says, we're told if Kenji plays a trumpet, then he plays a brass. If he plays a brass, he is a member of the marching band. So if we see Kenji playing the trumpet, what can we conclude based on this logic? Logically conclude based on this statement. Yeah, that he's part of the marching band. Good. We're going to see this today as we get into, we're not going to start proofs yet. We're kind of forming the foundation of the logical part of proofs. And we're going to see this today as we write through some theorems for parallel line angles. And part of that, I'm not sure we'll get to it till tomorrow, but part of that will be also using converses to prove things. So, or to think through it. So we'll get to proofs as the last topic of this unit, but today we're talking about parallel lines, and largely that's about angles. Even though we're talking about lines, what we're going to form is angles, and what we're going to see is we're talking about, let's see if I can get a color that you can see here. We're going to talk about parallel lines, and then a line that sort of slashes across them, what we call a transversal. And just me drawing that quick little sketch, how many angles do you see formed? Do you see 8 angles, right? And so like these 4 and then another set of 4 that are pretty much identical, or they are identical, just slid down. And so those 8 angles have various relationships that we're going to learn about. In fact, we'll call out specifically 5 different new ones in addition to the ones we have so far. So at the end of this, you're going to have about 10 different angle pairs that you need to know and recognize, be able to set up and solve with, and study. So 10 total, and then we're adding 5 new ones today. Anyway, so that's kind of what we're looking at for this next section. And these can get kind of busy. Like I could have a transversal going this way, and now we're starting to form triangles as well as these parallel line angles. Okay, maybe we have 3 lines and another transversal over here that's parallel to one of the first transversals I drew. And basically you'll need to be able to solve for any angle in that system. So maybe I give you a couple of these, like this top left one, and maybe this one or something, and I ask you for all the rest of the angles. And so with these relationships that we're going to learn, you'll be able to tell me what those are. So while I hand out a paper, I want you to look at this snowmobile track and answer the questions down at the bottom. You don't have to write them. You can just kind of think through it, talk to somebody about it, and I'll get you this paper while you're looking at it. Which angles look congruent? Just throw out some numbers. 8, 4, good. Well, 1, 3 are vertical. 7, 3. Yeah. How about 6 and 2? Okay, good. Which angles look probably like they could be supplementary? That's supposed to say look, not Lou. 8, 7 are linear pairs, so definitely. How about 7 and 4? Could they be? Yeah. So some of the ones that we know already or should are these kind. What are these 2 pairs called? Okay, listen. I just told you we're adding 5 more things to the 10 things or so that we have. Guys, if you're not studying your notes, you're not going to remember it, and it's just going to continue to build and overwhelm you. Having it in your notes or on your note card is not enough. You got to know things by looking at them. Study, please. Take time each night just to go over your notes. Those are called vertical angles, right? And what's true about vertical angles? They're congruent. All right, I already said what these are. What kind of angles are those 2? And if it helps, you can make sure you emphasize that this is a line and then this is the one that makes the angles. So what are those called? Those are a linear pair. They add up to 180. So you see a whole bunch of those in here, like specifically for vertical angles. 1, 2, 3, 4 of those, 4 pairs. And then for linear pairs, there's more because we can kind of work our way around. 1, 2, 3, 4. And so 8 different pairs of linear pairs that make straight lines. They add up to 180. So those are review ones. We've already learned those and done a bunch with them. The new ones will be ones like these two, or perhaps 7 and 3, those kind. And then 7 and 1, etc. Those are the new kind. So angles that aren't touching each other, they're sort of spread around the figure. And each of those pairs will have a name, just like we have vertical, linear pair, etc. Okay? So first of all, you don't have this page, but I'm just going to show you it briefly. Actually, let's do it this way. This line that's cutting across is called the transversal. And it's not that you necessarily need to know or be able to write that word, but I will say it quite a bit. And you need to be able to see it in contrast to the parallel lines. Sometimes we have parallel transversals. And I kind of showed you this at the beginning, but if I have another line cutting across here like that, now I have two sets of parallel lines. One set could be considered transversals, and the other set we would look at as the lines. But anything that's slicing across the other two, think of it that way, that's the transversal. Okay, so I'm going to show you these names and then we'll go to your paper. So we have corresponding angles. That's angles that take the same position on each set of lines. And then we have alternate interior, alternate exterior, and we'll have 2 pairs of these kinds, consecutive or same side interior. So grab your paper and we're going to start filling this out with lots of information. First thing I want you to do is take maybe a highlighter or a heavy pen and separate the top 3. And then separate these middle 2 from the bottom group. So we're creating 3 sections. And each section, well, at least the top 2, have traits in common that help you kind of group these together. Okay. So you're going to hear a conditional statement for each one of these. I want you to start at the top by writing, it says given parallel lines. I want us to translate this to the beginning of a conditional, which is the hypothesis part. If 2 lines are parallel. So initially we need to be told that, and then later we're going to prove that using converses. So if 2 lines are parallel, then see each box below. Okay, so we've got to know that the lines are parallel first. Then each of these things that we're about to write that's new, we're going to, they will be true as well. So alternate interior angles. If 2 lines are parallel, then alternate interior. Actually, I'm going to use this down here. So just that way we don't have to rewrite it. Then alternate interior angles are congruent. Remember, the symbol for congruent is an equal sign with a tilde. Okay, so alternate interior angles are congruent. Let's define what they look like. They are on opposite sides of the transversal. Inside parallel lines. Which line down here is our transversal? So they're labeled L, M, and N. Which one is the transversal? L. M and N are parallel. And we note that by showing arrows on the line. So maybe they didn't stand out real good on your copy, so I would go draw them in. And that's our notation for parallel, is arrows. Probably you can tell by now that in geometry we like lots of notation, so we don't have to write stuff. Okay, opposite sides of the transversal, inside of parallel lines. Here's how you can tell if it's inside. You don't necessarily need to do this right now on your picture, but you can if you want. If you make a box out of the parallel lines, anything inside that box is interior. So we're talking angles 2, 3, 5, and 8 are inside that box, or interior. So with that said, which two pairs are alternate interior? Good. So angle 2 and angle 8, angle 5, and angle 3. Do you see how they're on opposite sides of this line that cuts across? And they're inside of the parallel lines. So like these two are on opposite sides of the slash line in between the parallel lines. Okay, so alternate interior angles, that's our first pair, and they are congruent. Okay, next set. Again, we're starting with this statement every time. If two lines are parallel, then corresponding angles are also congruent. So if two lines are parallel, then corresponding angles are congruent. Corresponding angles take the same position relative to the parallel lines and transversal. In other words, you could slide one corresponding angle up and exactly cover the other, its corresponding angle. It's in the same exact position relative to the parallel lines and transversal. Okay. So I'll start you off with this one. Let's talk about angle 8. What other angle takes the exact same position in this figure? Angle 4. So if we slide, think about taking this whole set, 5, 6, 7, 8. If we slide that up, it will exactly cover 1, 2, 3, and 4. And 8 specifically will cover over 4. So 8 and 4 are corresponding. So angle 8 is congruent to angle 4. Let's list the other pairs of corresponding angles. So angle, what?
3 and 7.
Yeah. Angle 7 and angle 3. Okay, how about 6? Good, is angle 2. How about angle 5? Angle 1. Okay. So we have 4 pairs of corresponding angles in this system. Keep in mind we can add a whole bunch more lines. In fact, we will. And then this is why you need to study these, because when we start adding lines, it gets harder and harder to see the pairs. All right, next set. So alternate exterior angles. If two lines are parallel, then alternate exterior angles are congruent. Alternate exterior angles I bet you could define this after defining the first one. These are on opposite sides of the transversal. Outside this time of the parallel lines. So again, draw the box, but this time look on the outside of it instead of the inside of it. So we have two pairs. What are they?
1 and 6.
1 and 7.
1 and 6 are on, if I circle those, do you see how they're on the same side of the transversal?
1 and 7.
Yeah, there you go. 1 and 7. And 4 and 6. So those are alternate exterior. So what is the common characteristic of all these angles on the top? Why did we draw this pink line? They're all congruent. Yeah, good. So I'm going to come to the side over here. These are all congruent. And it doesn't fit on the screen, but it says these are all congruent. Okay, let's define the next set. There's only 2 of these, and that completes the 5 new ones. Okay, same side interior, or you can call them consecutive interior. I'm going to put that in parentheses. Honestly, most of the time, if not all the time, I will say same side interior because it's more descriptive. Okay, so let's see if you can come up with your own definition. Same side, what do you suppose that means, same side of?
Transversal.
Yeah, the same side of line L, the transversal. So they're on the same side of that. Interior means between the parallel lines. So before we even define it, because it's kind of defined by its name, what are some angle pairs?
2 and 8.
Yeah, 2 and 5, 3 and 8. Perfect. Okay. This time they are not congruent. So we're going to say angle 2 and angle 5. Angle 3 and angle 8. Because if you look closely, let's just look at 3 and 8. 3 is acute, 8 is obtuse. There's no way those are going to be congruent. Okay? But they do something else. What do you think it is? Yeah, so we're going to say, okay, if 2 lines are parallel, then same side interior angles are supplementary. But let's be more specific in that they add to 180 degrees. Let's go ahead and line out consecutive interior for this part, just so it's not so wordy. Okay, so angle 2 and 5 would add up to 180. Angle 3 and 8 would add up to 180. All right, and then same side exterior, basically the same idea, only now we're outside of parallel lines, okay? So give me some angle pairs for that.
1 and 6.
Yeah, good job. Angle 1 and angle 6. Angle 4 and angle 7. Again, let's scratch out consecutive exterior. Okay, so if 2 lines are parallel, then same side exterior angles are supplementary. So I did not spell that right. Supplementary. Add to 180. Okay, so over to the side, let's write the common characteristic. These add to 180. It says these add to 180. No, it cuts it off, but. So there's our 5 new pairs, 5 new angle pair types that we'll need to be able to recognize, work with, solve for, etc. The bottom section is review. So let's just quickly fill those out. Vertical angles like 1 and 2 are congruent. Also 3 and 4, right? Anytime you intersect two lines, you create vertical angles. Okay, linear pair, any version of this. Okay, these lines could be going anywhere, but they make a straight line. And they add up to 180. Supplementary, we've already said a couple times. They add to 180. Complementary, what do they do? Add to 90. Okay. All right. You need to have this memorized, honestly, because it doesn't really serve you much use if you constantly have to look these up. And so if you know them and you can recognize them, you're way better off. I'll show you some examples of pictures that we will be working on. I'm going to put this one on as your homework. I'll just screenshot it on there. That's a W. Anyway, I suck at that. Here's a little bit busier picture. See how there's two transversals? There's a triangle involved, so we'll need to know the triangle angle sum theorem of adding to 180 degrees. And there's linear pairs, vertical angles. There's all sorts of stuff going on in there. Tomorrow, we're going to do this one. Now we have 18 different angles that we'll need to solve for. So I need you to study these tonight so that you're capable of working with them tomorrow. Okay?
Do you just want to copy that picture?
The words are important. It tells you measure of angle 6 is 58.
Okay.
Yeah. But I will post it separately.
So just like use that and just write down.
Yep, that's okay.